and also reveal pregnant teens to parents based on their teens' purchase patterns at Target. So aren't there laws against abuse of information? What's supposed to protect us is the HIPAA rules, which came out of the act passed in 1996. And they provide two methods of de-identification. One so-called safe harbor and the other expert determination. Safe harbor, I think we're all pretty much familiar with. You strip out 18 standard identifiers, and you have then, along with removing any unique identifier that might be unusual, like genetics information. But once you've done that, you have a de-identified data set. It's compliant, can be released to anybody for any purpose. The expert panel requires that some sort of an expert pass on that knows statistical methods to determine that the risk of re-identification within a modified data set is, quote, very low. And the methods used to do this, you can see up there to the left, is that you can simply suppress patient values. On the other hand, on the right, it shows a method where you change ages into range or change zip codes from 5 to 4 or 3 digits. And that creates, if you can and you're supposed to document that we believe that this is an expertly de-identified data set and can be released. So when did this fall apart, or did it fall apart? And I apologize to those of you who are familiar with the Netflix prize. It certainly isn't healthcare, but I think it was a point in time when there was a sea change beginning in the informatics community about just analytics community about just how safe are our de-identification methods. In 2006, Netflix announced a contest to produce an algorithm that would help their customers choose which movies they would prefer to watch. This wasn't uncommon to crowdsource this sort of activity. $30,000 or $40,000 was often offered for these sorts of algorithms. But in this case, Netflix offered $1 million, and more than 20,000 teams signed up from all over the world. And they released to these teams, released publicly, 100 million user ratings that they said were de-identified. And in September of 2009, Netflix announced a winner. Now, Netflix never mentioned, or at least we don't think that, I think they mentioned, that during this contest in 2008, a group at the University of Texas at Austin had re-identified their customers. They developed what they called a group of de-anonymization attack algorithms, and with those algorithms, they were able to, with as few as 6 rated movies, identify the customer 99% of the time. And then they could look at other places on the internet where those users had made other postings, such as Internet Movie Database, and determine not only the user's identity, but even their political views. Well, Netflix didn't say much about this that I can find, but they were happy enough with this contest that they thought they'd do it again. So in 2010, they announced another new contest, and then the Federal Trade Commission stepped in and sued them, shutting it down. It's interesting in this country, while it's not illegal to re-identify healthcare information, if you're not a covered provider, a regular company, they can re-identify information if they have hold of it without penalty. But it is illegal to use re-identification methods to re-identify the videos that people watch. So about the time that controversy was going on, an article appeared in UCLA Law Review written by Paul Ohm, who reviewed the findings from the Netflix prize, along with some other so-called re-identification scandals. And this article has become a landmark article since it has been cited more than 1,400 times. But his conclusion, based upon the process in re-identification science, was that it has disrupted privacy efforts. And he said, quote, "We must abandon the pervasively held idea that we can protect privacy by simply removing personally identifiable information. This is now a discredited approach." Sorry there. In 2007, a letter came from a committee to the Department of Health and Human Services Secretary, from the committee who's charged to provide them with advice on privacy policy. And it was headed by William Steed. Many of you have heard of him, who's an informatics expert at Duke. But the committee concluded, based on the testimony they were hearing from experts, that the ability to do health outcomes research and the need for privacy were on a collision course. So what went wrong here? Reviewing a couple concepts: anonymization is a goal, de-identification is a method, removing identifiers. De-identification alone may not ensure anonymization. Sometimes methods don't achieve their goals. Another way to look at this is that when it came to the expert pathway, people were trying to develop techniques that would work without any idea of the context in which this data would be held. So-called de-identification and release strategy, or sometimes release and forget. Yves de Montoya, who is a computer scientist and privacy researcher at Imperial College in London, came up with a very succinct characterization of why this shouldn't work. Is that anonymization is not a property of a data set, but how it is used. So modifying the properties of the data set may not achieve the goals of anonymization. Since that time, the focus has shifted to data custody. Who's going to get this data and what are they going to do with it? And there's a number of approaches to determining whether data custody can be effective. One of them, which is the 5 safes: safe people, projects, data, settings, and outputs. So if we were trying to, remember, we were trying to design a system here that has good privacy, but basically provides great access to data for researchers. And remember, we promised earlier that HIPAA will not constrain us and we won't need data use agreements. So how do we design such a system? And the methods of designing this system depends upon a trusted privacy layer. De-identification is still an important tool. Maintaining privacy, though, now requires more attention to the custody. There's a difference between access and possession. Data use agreements often don't distinguish between these two privileges, but there's substantial changes in risk between possession and access to data. Data is held by a coordinating center serving as a trusted partner who does not re-release it. Users do not download data. Now, I understand that many users are sensitive about not being able to download data, and we'll talk some more about this in a minute. Custodian is bound by a contract to enable safe review of data and prohibit re-identification efforts. That is, you still need a data use agreement, but it's not held by each researcher, it's held by the custodian. You have transparency because you always know where the data is. There has to be shared expert governance to control access. That is, without governance and transparency, there's no trusted system. Also, to inspire researchers with rational access to high-value data, this has to work well. If we build it and they don't come, there's no point. So for those who may be questioning, is this really compliant? Health and Human Services has been suggesting this for quite some time. They issued post-rulemaking guidance back in 2012 that we should think about this kind of system. People had been under the impression that using the expert pathway involved using statistical methods to change the property of the data set, so the risk of re-identification was very low. Do we have to only use statistical methods? The first statement there, yellowed out, is the expert may also consider the technique of limiting distributions of records through a data use agreement. How should we do that? The second statement, the specific details of such an agreement are left to the discretion of the expert. So there's some flexibility here. And do we have to have a data use agreement with each researcher? The third statement, must a covered entity use a data use agreement when sharing a de-identified data to satisfy the expert determination method? No. Once data has been rendered anonymous by this method, it is not subject to HIPAA rules. So many of you recognize that what we're talking about are largely data enclave methods. Data enclaves are basically a business entity that uses, with a multidisciplinary experts, that engages in informatics, legal, ethical, technology, and governance techniques to create a safe environment from which to share data. In these cases, the contract is with a custodian to configure access, and they use a number of fairly sophisticated query-based strategies to restrict viewing of PHI. Access is controlled but role-based. You don't have to decide each user in each project who gets to do this. If an organization decides, we want all of our researchers to do this, they can do it, and at least there's no compliance issues. And the custodian has to monitor access practices and query activity. This is not a set it and forget it situation. You also need an engaged governance entity who can adjust to strategy based on emerging threats. This is an example of a data enclave. I think Cerner and Epic are both working on this for their customers. You have several organizations that want to share data. They send it to a coordinating center that stores the data and has to engage in a fair amount of data curation and data model work to make it usable for researchers who then have web-based access to the data. They can't download the data, but they can participate in data curation and data modeling, which is usually quite necessary, as you'll find out in the next presentation. This is, compared to what we're talking about with data privacy, the data curation model is a real challenge. So once the researchers can log in and see this, the analytic tools are on the website, and they just can't see line item data, but they can get any sort of research. This is not a limited data set. This can be PHI. You can look at 5-digit zip codes or exact dates because you're not seeing line item data. So this is effective anonymization. It's down the lower left of this slide. A trusted entity maintains custody, exposes aggregate results, not individual line item data. Hashed IDs can be used when linking data. Users can't download, and queries mask data when less than 11 rows. And there are other methods of securing anonymization, but that's an important one. So according to the expert pathway, custody-enabled de-identification is not subject to HIPAA, no IRB required, and no DOA is needed. So data enclaves can enable this strategy are already in wide use, most commonly used in social sciences research, and particularly for protecting victims of violence. The Census Bureau and CDC use data enclaves, but it's not commonly promoted as we are here as a remedy to HIPAA and IRB constraints. Some of these data enclaves are really quite interesting in that they perform a lot of services. The University of Michigan not only has several enclaves that they run, but a whole graduate school where you can take summer courses to study enclave operation and informatics principles. University of Chicago's NORC has more than 150 contracts with various organizations, including the government, where they bring their data to NORC to handle. These are the details of how you render a data custody environment safe. And I won't go through these, of course, but it's available in the presentation, along with the fact that any organization conducting this has to analyze their particular circumstances with a multidisciplinary panel. So nothing is perfect in the world of analytics. We lose something, but we gain something. Line item data can't be seen, but it can be looked at if somebody comes up, decides they need it, and a DOA is an IRB are obtained. Some details are lost with removal of identifiers, and data model and governance shifts to hosting entities, which can make a lot of researchers very nervous. But is it really a bad thing to have arguments between individual researchers and a standard hosting entity to come up with a data model. We need more of that, probably not less. The things that are gained is you have immediate access to test a hypothesis. You wake up in the morning with an idea, chances are you can go test it, presuming that the enclave has a self-service or role or allows peripheral researchers access to it with their own analysts. Sometimes queries have to be pre-approved. The user access is role-based. You can analyze PHI if you're only seeing aggregate results. No requirements for HIPAA or a data use agreement or IRB. Enables huge databases, and that seems to be what's happening, is that organizations, when they know who's going to get the information and how are they going to care for it, are more comfortable with this. Also, organizations may be more willing to share data because I think a lot of research administrators and lawyers, at least the ones I work with, are very nervous about donating data where they just send the data off and they aren't really sure of the organization's practices. And the data is going to be out there for 5 or 6 decades being used for who knows what by some secondary or third partner. So making it so you always know where your data is, and if new threats emerge, that you at least know where you can go to have a conversation about what can be done. So our contention is that better privacy protections can enable wider sharing of data. This is a plan. Now we can move on, I think, to the state of the art that Mark is going to discuss, but back to you, Jennifer.
Thank you, Dr. Josie. That was really great. And I felt like for me, it puts a lot of things in context and a lot of moving parts that we see in the market around this and trends that really kind of anchors it in some really important basics and identifying the trends and what direction we're going in and why. So I'm going to turn it over to Mark Rosenman, who is an associate professor here at pediatrics at Lurie Children's. He's a health services researcher and specializes in using very large, complex data sets to do his work and to make data available for other researchers. He is our site PA for PCORNet and is also our liaison for PedsNet. So with that, I'm going to turn it over to Mark.
Thank you. I'll share my screen here and just maximize this and then move the pictures out of the way. Challenges, opportunities, and lessons learned as a children's hospital participating in PCORNet or in any multilateral endeavor. I'm happy to be working with this team, including George, Rachel, and Mark Bennett, and as well as Jennifer and many others at Lurie Children's. These are the main 4. COI disclosure, I have no relationships with commercial entities. Just as Jim did, I'd like to start with a cautionary note. And I would commend this article to you by Clem McDonald, formerly from Regan Street, now with the NIH, one of the pioneers of EHRs and EHR research in the US. It's called Computerization Can Create Safety Hazards, a barcoding near miss. And the essence of it was that Clem was commenting upon an incident at a hospital where a patient in the ED had incorrectly been given 2 different wristbands. And the point of this figure, which was his figure in Annals of Internal Medicine, was to show that the font on the wristband is about the same size as that on a quarter and much smaller than that on a Regan Street Institute party tag. Sometimes I'd like to just start with this slide so that it says I'm John Smith instead of putting my name out there as the first slide. If you remember any shape from today, I hope you'll remember this figure, which was created by Jeremy Carroll, a British mathematician at Hewlett-Packard. He figured out a way to create a 6-set Venn diagram fairly easily. And I've adopted it and have used it in some of our activity here as well as elsewhere to try to help in looking at overlaps between sets of different institutions or other different sets filling in the numbers into a template like this. And when you begin combining data from multiple institutions and create Venn diagrams like this, you can put the institutions A through F here as an example. Each of the different intersection zones may reflect something of interest, some distinct data or interpretation challenges. As one example, for Lurie Children's and our neighbor, Northwestern, there are some hospitals out in suburban Chicago where the hospital is owned by Northwestern and has a Northwestern EHR system. But some Lurie Children's physicians also go to the hospital and create some records that make their way back to the Lurie Children's system. So when including that type of a hospital in a multi-site research project, that's an area of complexity right there. And then there may be other combinations in all these other zones. And then if we go to the very center, you can imagine that the patients who visited all of the institutions, or say 5 out of 6, they may be different in some important ways. And we found in the past that they might have disproportionate amounts of housing instability, complex multiple issues, illnesses, mental health challenges, substance abuse sometimes, and other distinctions that add to the level of challenge for putting the data together and for interpreting the data in research. And some of those might be, there can be geographic distinctions between all of these different zones. In a Venn diagram like this, healthcare coverage varies and the data types and completeness, and we'll get into some of these as we move forward with the slides. So the main take-home message from today, and I asked George what his main take-home message was, and he agreed that complexity increases with the number of institutions involved in the study, and it's not linear. I think it's exponential or something like exponential. So if you remember one line figure, please remember this one. And our 3 main take-home messages are that as the number of institutions increases, complexity increases exponentially. Standards, harmonization, and coordinating centers are all helpful, but only up to a point. We'll discuss that further. It is vital to have a historian, or more than one, such as George, who can look back over how the EHR has changed and how the data feeds into our common data model, data mart, may have been affected by that. PCORNet, for those who don't know, is the National Patient-Centered Clinical Research Network that was founded by PCORI about 5 years ago. It has about 65 sites across the US in a distributed network. The coordinating centers are at Duke and Harvard. It has data from 2011 to the present. About 66 million patients nationally, and Lurie Children's has about 630,000. We joined in 2015. The goal, according to PCORI, was to make it faster, easier, and less costly to conduct clinical research than is now possible by harnessing the power of large amounts of health data and patient partnerships. This is the heart of what we do in PCORNet. PCORNet, meaning Duke and Harvard, issue these data mart specifications. This is version 5.0. The red circles are what they added in moving from version 4 to version 5. And what we have to do every quarter, we redo this with a refresh of the most current data, is take the various upstream sources, in our case, Epic Clarity, and extract, transform them, and load them into the PCORNet specifications. As many of you know, PCORNet is one of the common data models out there. There are also the OMOP model and the I2B2 model. Those are the big 3 in my mind. I know there are others as well, but so you can imagine that a lot of work goes into this, and we'll discuss some of these specific data issues as we go. In addition, from April of this year up until now, we've implemented a bunch of COVID-19 enhancements. And that has been a successful separate project in which a lot of the sites are using PCORNet to the extent possible to describe some additional COVID-19 data patterns. As George knows, he has a new assignment for January 2021, which is when PCORNet switches to version 6.0. The main specification changes there, to give you a sense of it, is that we have to add telehealth into the encounter types. And email visits are under discussion for those sites that have them. We have to add chief complaint into the condition data. And there's a new table called lab history that is optional that's going to get into the historical normal range changes that have happened. We do have a way of including the current normal ranges. The administrative efficiencies of any multi-site network like this go beyond just having the common data model. And here, instead of PCORNet, I used a PedsNet slide because I thought Dr. Chris Forrest, the executive director of PedsNet, summarized this succinctly. So beyond the data mart, there's potential efficiency in data sharing agreements, confidentiality agreement, uniformity or harmony, a shared IRB when possible, data governance, streamlined contracting, and an improvement system to further streamline all of the above. All of these things work up to a point. I'll repeat that phrase probably more during the talk. So they are helpful. It's just not, this is more the goal, not where we are today with any of these networks. And PedsNet, I just wanted to note that Children's Hospital Colorado and Seattle are two of the founding members, and we are hoping to join because PedsNet seems like a great place to do children's health research. This is also a slide from Forrest at CHOP showing his vision that the institutions here are shown as the vertical bars, at least the founding 8, and more are to be added. And then cross-cutting networks in different specialty domains can be established, autism, nephrology, cardiology, etc. And each of these can develop additional knowledge of the data and the metadata. We recently submitted a proposal to epilepsy experts at Lurie Children's, who were the prime investigators, Ann Berg, PhD, and Sandy Lamb, MD, on Lennox-Gastaut syndrome. And when we queried our own system, we found 260 patients who have this rare, severe epilepsy over the past 5 years. But we sent out prelim queries to other sites. George helped write them. And when we include PedsNet plus about 10 other children's hospitals from elsewhere in PCORNet, we get our numbers for this proposed study up above 3,000. So we're keeping our fingers crossed that this will be funded. We'll find out next year. A quick overview of what PCORNet, the network, is. This is not meant to reflect all of PCORNet, but in the bottom left, I show Capricorn, which is the subnetwork of the Chicago institutions, about 10 of them. And then at the bottom right, I show PedsNet. I showed you the institutions there before. I've included Lurie Children's there too with a dotted line. In the upper left is another one of the subnetworks, Greater Plains Collaborative, which is where IU School of Medicine is. And up in the right, those are not individual institutions, but just some examples of the other networks across the country, including one Florida, which has about 8 or 10 sites from Florida, and ReachNet, which is in Louisiana. Now, one element of the complexity is if you look at the Chicago institutions, they have a different share of the total Chicago market depending on what dimension you're looking at. If you're looking at total adult acute inpatient beds, then these 10 institutions have about half of them. But if you're focusing on labor and delivery beds, it's only about 30%. Because as you can see from these institutions, they're mostly the academic centers. There's one community health centers network, and there's Cook County Hospital. But when you put these all together and look at outpatient visits, you get an even smaller percent of the totality of Chicago outpatient visits. PCORNet's quarterly refreshing curation and report card. This is really how we spend a lot of our time in the project. We write the ETL procedures that turn our Epic Clarity data into the data mart, map a lot of local data elements to standard vocabularies. We passed the test in 20 of 20 quarters. Now in the past, they've said anyone who doesn't pass is going to be kicked out for a quarter. But I'm not sure if they really do that or if you have to fail pretty badly to be picked up. They seem to be able to work with you if there are any issues. And within the report card, this is where I give the Coordinate Coordinating Centers high marks, because they send us SAS queries that generate aggregate data with which they evaluate us. And this is just one example from a long report where they're graphing our immunization data trends over several years. You can see the October seasonal spike in this standardized y-axis. But these are the things we look at, and where any deficiencies are noted, we have a 3-week sprint every quarter to try to fix anything. And there are certain red flagged items that must be fixed in order to pass. There are some blue flagged items that are kind of like a grade of a B, and some of those are okay. One thing they grade us on is RX norm. For those who don't know, RX norm is a standardized medication coding system that's developed by the NIH. And I just pasted in a screenshot from their RxNav website to show you amoxicillin. The amoxicillin ingredient code is 723, and ingredient codes can be useful for some purposes, but in PCORNet, ingredient codes do not pass muster. We have to map our medication records to what's known as a tier 1 code, which are some of these others that you see down here that actually convey not only the ingredient, but also some information about the dose and strength and combo products involved. And one has to have a score of 80% of your med records mapped to a tier 1 RX norm in order to pass. At one point, about a year ago or less, they sent out a report card summary for all the institutions, each institution being a bar on this chart, and Lurie Children's was here. At that point, we had just surpassed 80. So we were getting a grade of A- there. Since then, we've improved much further above 80. But I want to show you some of the challenges we faced with RX norm. As I mentioned, it has to encode the ingredient, strength, and dosage form. Our initial result was 74%. So we weren't failing, but we were in that blue zone. We looked closely into why this was the case, and just starting with meds, just using meds that start with the letter F, we have these: Flintstone vitamins, face masks formula, fiber fish oil foam bandages, food supplements, foot care pads, and Father John's cough medicine. Some of these you'd imagine are not really exactly meds at all, or they're the type of meds that would be difficult to map to an RX norm code. So we did our best. We fixed a bunch of things. We also talked with PCORNet and said that as a children's hospital, this is I should make as well, that a lot of the PCORNet specifications are not written by pediatricians. And as we all know, children's hospitals have special data. So we convinced them to change their grading system, and we also improved our mappings. And this is just a picture of Father John's cough medicine, which was initially created as cod liver oil in, I think, about 1850 in Massachusetts, but now has different ingredients. Beyond those that start with F, we have a lot of topical lidocaine J-tip injections into children's hospital, special records from randomized trials, and all kinds of diverse IV piggyback formulations for distinct infants' weights. Those you can't map to RX norm, at least to the tier 1 codes. And we discussed this with PCORNet and got them to change some of their grading systems as well. Lab mapping is another issue that PCORNet looks at closely. And over time, not only in our data mart, but I think across the country, everyone is improving in response to this evolutionary pressure. At the time of this, about a year ago, you can see that we were right here. We were barely above 80%. We've made more improvements since then, but let me show you some examples of what we had to work through. We have to map our lab test names to LOINC codes, which I'll discuss in a second. But in addition to the test names, they focus on the units of measure, and these are so diverse. I mean, we're all familiar with various things like milligrams per deciliter, but there are these units like EU per DL in our data system when we had to figure out that that meant Ehrlich unit per DL, which is used for urobilinogen, and we had to map to the complement activity enzyme. The bottom two on the top are percent of hemoglobin A and percent of hemoglobin S in hemoglobin electrophoresis, but the correct map value is just the percentage because the A is reflected in the test name. So these are the types of things that trip us up, and when we improve upon these mappings, we improve our score above 80%. Sometimes also the specimen source is an issue. In this case, our raw value was truncated as alkaline phos plasma O, but what that really means, if you talk to the lab people, is plasma or serum. So we were able to map it to seer_plas. George is constantly doing a nice job of going to the multiple upstream EPIC tables and wrangling them in to the single relevant table in the data mart. So for procedures, he goes to at least these three sources, two of which are billing related, and links them, joins them. We noticed between April and July of 2019, those two quarters, that a lot of our procedures in this Venn diagram moved into the order table represented by the circle at the top. And that was because George figured out new and improved ways to join those together. And so we moved some out of the lower right up into the middle intersection zones. I went to a standards conference at Mayo Clinic several years ago that talked about LOINC codes. They are common mapping terms for test names founded by Regan Street. And I knew going in that one of the issues is that LOINC codes are meant to take all of the various local terms across the country for something like A1C and collapse them down to a much more reasonable set. There are still different LOINC codes for A1C, theoretically, because there are different machines that run the A1C, and if you mapped it exactly correctly, you could map it to the right one. But in my opinion, sites are still doing a great job if they at least get A1C into one of the somewhat relevant bins. And in fact, that's what happens. You'll see in a second. So for a project led by Nori Allen at Northwestern, she's the PI of a childhood cardiovascular health trajectories project, George and I had to write a query to reel in data on A1C as well as some cholesterol, the different types of cholesterol, glucose, and blood lead. And it led us to create this list of LOINCs when we gathered some metadata from the sites involved to see what all the different LOINCs they were using. And for each of those tests, it varied by site as to which LOINC. So we cast a wide net and brought all these in. But remember, I said this helps up to a point. There still are local terms in use that are not fully mapped at each of the sites. And we reached out to the sites to ask them about those. And we found that we then had to write some tailored SQL when we're sending SQL out to these sites to gather data in for Nori. And at one of the sites, we sent them this SQL statement with the LOINCs, plus this list of about 30 local terms at their own site. I've de-identified their actual lab code numbers, but you can see the variety of lab terms that they use. So LOINCs and standardization and harmonization helps, but only up to a point. When I went to that Mayo conference, I told them, you're doing a good job dealing with your analysis LOINC codes, but what about the result values? There are all these variants just from one hospital. And if you imagine doing this in multiple hospitals, there are going to be many, many more that someone then has to collate and make into meaningful post-processing categories. So this is in decreasing frequency. You can see the different variations of yellow. And there's another page with the yellow without the W, like in mellow yellow. And my last data type to mention is insurance status. One hub had asked the sites to map its values into these 6 categories, but hadn't given any instructions as to how to do it. So one of the sites wrote this SQL, which just said, if Medicare, then Medicare, if private, then private, if free, then free. That isn't going to work because Atlanta Healthcare Plan doesn't have Medicaid in the name, but we know that it's a Medicaid plan. And Land of Lincoln National Freedom Gold is not free. In other words, someone without insurance, it's actually a private insurance plan. And the raw data also has, from that institution, has Land of Lincoln National Freedom, with freedom misspelled, bronze. So because of the misspelling, this one just gets put into the other category, as it didn't attach itself to, it doesn't have the word private for private, and it doesn't have the word free for free. So when that particular poorly written bit of code, when I compared it to how I would have categorized that site's insurance statuses, the agreement was only 9%. Another site sent me its code. It was much better. I agreed 45% of the time with them. And overall, the pooled institutions mappings against mine, it was a little under 35% with the results on the diagonal. This is just a quick slide to say that the complexity issues I've mentioned apply not only to all the topics we've discussed, but also to research ethics and to data privacy and security, as Jim was mentioning. There are complex issues involved in all of these. And while some common data agreements can help up to a point, there also are additional privacy and security risks when multi-site data are involved, especially when, as is planned, merging external non-network data sources is on the horizon.
Great.
What?
Sorry.
Thank you.
Thank you, Mark. That was really great. And so, yes, it's kind of like a Rube Goldberg too, but I like that picture better. So I think we've just had a really good picture of kind of macro issues around data governance and data sharing, and kind of micro issues around data governance and data sharing, and how both of these are kind of enormous oceans of problems that we need to walk through. And so I'm happy to entertain any questions. Amanda, do we have any questions ready? Otherwise, I'll fire away a couple questions.
Not yet, Jennifer. Go ahead.
Great. So, you know, as a researcher, when I first started doing research a long time ago, my boss used to say, you have to get data that squeaks so loud, so squeaky clean you can hear it. And I think one of the challenges we have here is not so much, it's not dirty data. It's data it's clean enough to do clinical work off of. It's just whether or not that data can turn into something that's viable for research. And then we have this other problem on the other end of, once you get it that way for a certain organization, how do you match that up so that it becomes valuable across organizations? And so I guess it seems to me that Duke and Harvard are doing a good job of constantly updating their data standards, but I'm wondering what either of you say about kind of the cost of doing this and how it can get to a point where it becomes something that the databases are more responsive to researchers and more able to be, or can be a little bit more nimble. It sounds like no matter what right now, that getting to squeaky clean is going to require us to not be so nimble. So just really interested in both of your perspectives on that.
Do you want me to start, Jim?
Sure, sure.
Okay. I think there may not be the easiest of solutions, but a couple of things come to mind. One is those cross-cutting specialized research interest networks, autism, nephrology, neurology, et cetera. Each of those can build its own metadata libraries, its own query libraries, and then share those more widely. Mm-hmm. Each of these networks, like pCoreNet and OMA, also make sources available and fully available. I think one additional thing is that if some of this ultimately can be shared with the upstream feeds, if Epic and Cerner and others can build upon this too, to take a little bit of the burden off of us down at the downstream side.
Great, thank you, Mark.
Yeah, I think that we're in an era of going through, if it will be a productive transition, going through the professionalization and business maturity of data storage. I think up till now, we're often kind of like we were in the 1980s with EMRs were academic institution properties, each individual, but how could you possibly share? I think there's a lot of discussions among data enclaves is how can you have a business model that survives? I know that PedsNet is going through that because it costs, a few $100,000 a year for people to join that. I think there's a huge amount of expertise within all of the partners of these things, but often they aren't the maturity level of the process of sharing data and these steps you go through may not be really what it should be compared to what we can achieve. And I think as you get multidisciplinary teams in to develop standards that people agree on, hopefully we can get towards a higher level of maturity in data sharing.
Great, thank you. Amanda, do we have any questions that have popped up?
No questions.
Can either of you talk about the role of, we've hired a data librarian in our department and to help us keep track of code and changes in the EMR over time. Mark mentioned that George, who is his ETL developer, has a long history at the hospital, so he has a lot of this stuff in his head. And well, hopefully documented somewhere, but that there is a dependency right now in looking, when we're aggregating data over time, there's a dependency on the ability to archive changes in the system. And so I think that that's just another dimension of how we need to understand, kind of going backwards and forwards. And so interested in how either the kind of the more micromanagement of the system or the higher level management of the system takes time into account in terms of updating records and going back and forth. I mean, take for instance, somebody who has some symptoms and a year later is diagnosed with a very serious illness. How does that play out in their records? And how does that show up for researchers and in these kind of big multiple data sets? Is there an effort to do that over time, true up somehow?
Yeah, that's maybe a better question for Mark in terms of his experience. I think in some ways you're describing the process of supporting analytics, and I have about 60 people in our business intelligence group that do database analysis work, looking at specific way they set up data marts, what's the source of the data dictionaries. And it's something that requires a business process that unfortunately aren't standardized across the country and even within an organization. I mean, people fight over what is a length of stay. Mm-hmm. So I think I can hope that new techniques, and even people talk about AI might eventually be used to deal with data curation episodes. That is, how do these things appear in the medical record and how can they be commonly understood compared with everything else going on?
Mm-hmm. Thank you.
In addition to George's personal knowledge of the history, he also has helped me since I just got to Lurie Children's a little bit less than 5 years ago. He also knows whom to ask, the various specialists who might know where the procedure billing data came from and the diagnosis data, so the lab information systems. So he's a liaison in that way as well. Mm-hmm. The deeper challenge about the longitudinal data you mentioned, Jennifer, is so interesting and challenging. I mean, as you know, right now we have to always operationalize. Okay, we're going to say that chronic use of this opioid they had a prescription for it, and we just say a time window of 4 to 6 months ago plus the past month. And I think this is one, is A related to B, we operationalize in so many different ways. Different researchers do it in different ways. And if our librarian can quickly kind of it's going to take like a Library of Congress, I think, but able to put something together over time.
Yeah. Maybe we're just at that time Thomas Jefferson is giving us his first set of books when it comes to this multi-institutional work. Well, I really want to thank you both very much for presenting today. It was a really great presentation. For those who've been attending, we will make it available online, probably in the next week or so, with the other presentations from the summer. So thank you all very much. Really appreciate the great contributions of our panelists, and have a wonderful weekend. Thank you.
Thank you.